Hi there. I'm Renee Dawson. I'm an educational technology consultant, and I will be your guide on our machine learning journey in this video. To start, we will go over the basics of machine learning. Then we will explore the three primary types of machine learning with a specific example of each. Are you ready? Let's go. As an educator, you know that humans learn from their past experiences. However, machines require instructions given by humans to work. But what if humans could train machines to learn from their past data to do what humans can do, but faster? That makes up part of what machine learning is. Machine learning is a part of AI where the machine uses algorithms, a process or set of rules to be followed in calculations or other problem-solving operations that learn from data to make predictions and improve their accuracy through use and experience, instead of being explicitly programmed to do so. Now that you know what machine learning is, let's check out the basics of how it works with an example. This is Ethan. He listens to music on a streaming app and especially enjoys newly released music. He either likes or dislikes the songs he hears based on his particular taste in music. He enjoys songs with a slower tempo that he can sing along to as he listens, and maybe even learn how to play on his guitar. If we were to take the last 10 songs that played on his music streaming app and graph them, this is what we would get. So if a new song has a tempo so fast that he can't understand the lyrics to the song, do you think he would like or dislike the new song based on the data on the graph? Exactly. He would most likely dislike the song and hit the thumbs down button on the app. But what if the next song that plays has a medium tempo and he feels like he could sing along after listening to it a few times? Would he give that song a thumbs up or thumbs down? If you thought to yourself, I don't know, then you're correct because the choice became complicated and unclear. Let's add that song to our graph right about here in between the songs he has liked and disliked. But how can we figure out whether he liked the new song simply based on this data? Well, that's where machine learning comes in. If we go to our graph and draw a circle around the song in the middle, we see that there are 4 songs he has liked within the circle and only 2 that he has disliked. So based on the larger number within the circle, we can say that he will definitely like this new song. We call this an algorithm, which, if you remember, is a process or set of rules to be followed in calculations or other problem-solving operations. That algorithm was pretty easy to use to identify his feelings about the first song, right? So what happens when the choices become complicated, like with the second song he listened to? Well, this is where machine learning lends a hand. It looks at and learns the data, then builds a prediction model, and when a new data point comes in, it can easily and quickly make a prediction for it. Just remember, more data plus a better model equals higher accuracy. The machine learns in 3 ways: supervised learning, unsupervised learning, or reinforcement learning. Let's take a look at each one with specific examples. Let's look at supervised learning first. Supervised learning in machine learning can be easily understood by comparing it to a teacher-student relationship in a classroom. Imagine a teacher trying to teach students how to identify different types of fruits. The process would look something like this. The teacher shows the students various fruits and tells them the name of each fruit. Students observe the characteristics of each fruit, such as color, shape, and size, and associate them with the correct label. The teacher gives students new fruits to identify, and they try to apply what they've learned. The teacher corrects any mistakes, reinforcing the correct associations. After enough practice, students can correctly identify new fruits they haven't seen before. In supervised learning, this process is mirrored with machines. The labeled training data acts as the teacher's examples. The machine learning algorithm is like the student, learning to associate input features with correct labels. The training process is similar to the practice and feedback loop. Supervised learning uses labeled data to train the model. Once trained, the model can make predictions on new, unseen data, just like students identifying new fruits. Next is unsupervised learning. Imagine a classroom where students are given various objects without any labels or explanations from the teacher. The teacher gives students a collection of various objects without naming or categorizing them. Students examine the objects, looking for similarities and differences in their characteristics such as shape, color, size, and texture. Without guidance, students start grouping objects based on the patterns they observe. Students create their own categories and labels for the groups they've formed. As more objects are introduced, students adjust their groupings and may discover new patterns. In unsupervised machine learning, this process is mirrored with algorithms. The unlabeled data acts as the collection of objects without predefined categories. The machine learning algorithm is like the students, exploring the data to find inherent patterns and structures. The clustering or pattern recognition process is similar to how students group objects based on observed similarities. The resulting model can identify new patterns or group new data points, much like how students might categorize new objects they encounter. Unsupervised learning uses unlabeled data to train the model. Unsupervised learning is particularly useful for exploratory data analysis, allowing machines to find insights that humans might not have anticipated, making it a powerful tool for uncovering new knowledge from data. So far, we've seen that supervised learning uses labeled data and unsupervised learning uses unlabeled data. But what about the third type of learning? Reinforcement learning. Well, that's just like you probably are thinking, reward-based learning, just like in some of your classrooms. Let's dive deeper into reinforcement learning. Reinforcement learning in machine learning works on the principle of feedback. It can be understood through an analogy similar to a student matching pictures to the word the picture represents. When students work on an activity independently, they learn through trial and error. For example, you have several index cards with words written on them on the student's desk. You show the student a picture of a dog and ask them to find the card with the word that matches the picture. However, the student hands you the word cat. So you give the student negative feedback and tell them that it is a picture of a dog, and you show them the index card with dog written on it. The next day in class, you do the same activity. But this time, when you give the student a picture of a different dog, they hand you the index card with dog written on it because they have learned to associate a picture of a dog with the word dog. Reinforcement learning represents a powerful approach to machine learning that mimics the way humans and animals learn through interaction with their environment. It's particularly suited for sequential decision-making problems in uncertain environments. Those are problems that occur when an agent has to make a series of decisions in an environment. Each decision affects not only the immediate outcome of the problem, but also the future states of the environment. A classic analogy is playing a game of chess, where each move influences the subsequent moves and the overall outcome of the game. The challenge in problems like this is to devise a strategy that optimizes a certain objective, such as maximizing the total reward or gain, or minimizing the total loss or cost, over the entire sequence of decisions made in the game. Let's look at a flowchart to help us understand the machine learning model. Input is given to a machine learning model, which then gives the output according to the applied algorithm. If it's right, the output is the final result. If it's wrong, we give feedback to the training model and ask it to predict the correct response until it learns it. Machine learning is possible in today's world because of the large amount of data available to train the models. Whenever you're online, whether you're buying something or just browsing the internet, that generates a large amount of data. That data is the key to analysis. So now you have a basic understanding of machine learning and its three types. Machine learning is a kind of artificial intelligence that allows machines to learn from the data they receive without being explicitly programmed to do so. The three types of machine learning we discussed were supervised learning, which uses labeled data, unsupervised learning, which uses unlabeled data, and reinforcement learning, which is rewards-based learning. I hope this video helped you to gain a basic understanding of machine learning. Thank you for watching.
See you next time.